everybody. Welcome to the polynomial review, getting ready for test 4. In this video, what I'm going to do is I'm going to show you the answer, and if you need to see how to work the problem, you stick around for it. If you got the answer right, then you can move on. This is worth extra credit. There will be a place for you to turn it in. It's called turning in a polynomial review. It is worth, each question is worth a half a test point. So if you have all 20 of them completed, all the work is shown, all the correct work, correct answers, everything, the multiply to check, if everything is there, you can get up to 10 extra credit points. It has to be turned in by Friday at midnight. If you do not turn it in by Friday at midnight, you lose your chance to get extra credit with this. It is different than turning in a homework. You can take multiple, it's not like one problem is going to be there and you take a picture of it. You can take like a picture of the whole entire sheet, like the front sheet, the back sheet, all of that stuff. If you have the worksheet that I gave out, if you have it all on notebook paper, you need to make sure that it's numbered. I know which problem you're doing. It's nice and neat and organized. The pictures cannot be blurry, so sometimes people take it where there's not good light or they're moving or something like that. So you need to check the picture before you actually turn everything in. If I can't see it, I can't grade it, and it's too late at that point in time. So double check, make sure your images are all good. So hopefully you understand that if you've got the problem right and you checked your answer, you can go ahead and move on to the next problem. So here is problem number 1. Here is the answer to problem number 1. So if you're good, go ahead and move on to problem number 2. You can skip ahead. If you did not get problem number 1 right, we need to work on it together. So what this is this is a binomial squared, so that means that you need to write it twice. If you do not write it twice and multiply it, you have killed a puppy dog and you made Miss Phoebus sad and I might cry. So because it's squared, there's 2 of them. And then we're going to multiply. 2x times 2x is 4x squared. 2x times negative 7 is negative 14x. Negative 7 times 2 is negative 14x. Negative 7 times negative 7 is positive 49. We're going to combine our middle terms. We're going to end up with 4x squared minus 28x plus 49. All right, let's look at number 2. Here's the answer to number 2. All right, this is a slide and divide problem. We are going to slide that 3 to the end. There is no greatest common factor, I should say. You should have looked for greatest common factor. But because there isn't one, other than 1, we're going to slide. We're going to find 2 numbers that multiply to give us 6. Those same 2 numbers have to add to give us negative 7. Those numbers are negative 6 and negative 1. So that means my parenthesis looks like x minus 6, x minus 1. All right, we did our slide, our factor. Now it's time to divide. What do we divide by? We divide by 3, and you have to simplify the stuff. So it'll be x minus 2. X minus 1/3 is already simplified. And then that divide by 3 can go up in front and makes this x minus 2, 3x minus 1. Now, of course, if you have 3x minus 1 and x minus 2, those are the same thing. They are equal to each other, so that one's okay too if it's written backwards. So that's problem number 2. Here's problem number 3 and its answer. So if you have problem number 3 right, you can go ahead and skip to problem number 4. If you missed number 3, let's look at it. So I've checked my coefficients. Those are all divisible by 5. It's my greatest common factor. These are in standard form, m to the 5th, m to the 4th, m cubed, m squared. So because it's in standard form, I look at the end. Do you still have an m squared? That means that I can take out an m squared. So when I distribute my greatest common factor in, I will add exponents. When I am taking the greatest common factor out, I'm factoring, I'm going to subtract exponents. So I'm going to divide 15 by 5 and get 3, and then I'm going to subtract the exponents on the end. 5 minus 2 is 3. 25 divided by 5 is 5. m, exponents, 4 minus 2 is 2. Negative 20 divided by 5 is negative 4. M, subtract the exponents, 3 minus 2 is 1. I can put a 1 here, but it's not required, so I'm going to erase it. All right, and then we have 30 divided by 5 is 6. 2 on my exponents, minus 2 is 0. Don't have any m's. There we go. All right, here is 4. Here is the answer. If you've got number 4 right, move on to number 5. The key to getting number 4 right is setting it up properly and remembering to put parentheses around your second term or your second polynomial. So we're going to have 7x cubed plus 5x squared minus 8x plus 3. You could wrap that in parentheses. It's not necessary. Here is where parentheses are necessary. 10x squared plus 3x squared, I'm sorry, 10x cubed plus 3x squared minus 8x minus 3. And what we're going to do is if we don't have those parentheses, we would just subtract off the 10x cubed and that's it. But we want to distribute so that we're subtracting the whole entire polynomial, everything. Okay, so we're going to have 7x cubed plus 5x squared minus 8x plus 3 minus 10x cubed minus 3x squared plus 8x plus 3. And then we're going to combine like terms. So 7x cubed minus 10x cubed is negative 3x cubed. And then we have 5x squared minus 3x squared. 5 minus 3 is 2, so we have a positive 2x squared. We can only combine like terms. Notice my exponents aren't changing when I'm doing this. Then I have a negative 8x and a positive 8x, so that's going to cancel. That's 0x. You don't have to write 0x. And then I have a plus 3 and a plus 3, so I get a plus 6. All right, so that's number 4. Here's number 5. If you get number 5 right, go ahead and move on to number 6. All right, in this one, this is FOIL. We're going to do first, outer, inner, last. So first, 3u times negative 4 is negative 12u. Outer, 3u times 5u is 15u squared. Inner, 1 times negative 4 is negative 4. Last, 1 times 5u is 5u. Then we need to get in standard form and we need to combine our like terms. Because the original was out of order, we can't just combine the middle two terms. Here are the terms we can combine. So we have 15u squared. Negative 12 plus 5 is negative 7u minus 4. All right. Here's number 6. The volume of a rectangular prism is length times width times height. So here's our length, here is our width, and here is our height. And what we're going to do is we're going to multiply them all together. What I like to do is I like to go ahead and distribute this 8n. And so I've got 24x plus 56 times 2x minus 5. And then I'm going to FOIL. I'm going to do that double distributive property. And I know 24 times 2 is 48, x squared. 24, I'm pulling out my calculator, times negative 5 is negative 120x. 56 times 2 is a positive 112x. And then 56 times negative 5 is a negative 280. I'm going to combine my outers and my inners. 48x squared minus 8x minus 280. That is the volume of this rectangular prism. All right, here's number 7 and its answer. Now I expect you to stop here on number 7. Okay, because this is new, we have an extra variable we have m's and n's. Notice that in the coefficients 2, -30, and 112, we can pull a greatest common factor of 2. But here I have an m squared, an m, but there are no m's here. There's an n squared and n, but no n's here. So I can't pull out a greatest common factor with my m's or n's. So here's what you're going to do. We're going to go ahead and we're going to pull out a 2. And I want, just for a moment, I want you to pretend like the n's aren't there. We're going to come back to that. But we're going to just be dealing with m squared minus 15m plus 56. And we're going to factor that. The n's will say for the n. You know how to factor this. We pulled out that greatest common factor. This is now we're ready for our blanks. Find two numbers that multiply, give you 56, and add to give you -15. They are -7 and -8. So that means I've got 2m minus 7, m minus 8. And so we would be done here at this point. Now we go back to the idea of the n's. I know that m times m gets me m squared at the beginning, and these are at the beginning of the parentheses. What can I do to get n squared at the end? Well, n times n is n squared. I want it at the end, so I'm going to stick it at the end of my parentheses. Let's multiply to check. So let's see. I'm going to distribute that too. So 2m minus 14n, m minus 8n, 2m squared minus 16m n minus 14. I'm going to put m and then n, but I have to know that those are like terms I can combine with the -16. And then plus 112 n squared. And then these guys combine to get me 2m squared minus 30m n plus 112 n squared. Now remember that you can have your notes, you can have practice problems out, so you might want to on this kind of star highlight it and know that n, or your second variable, is dealt with at the end of the problem. Okay, so just keep that in mind that we only picked up this at the very, very end where we were about to say, hey, this is our answer. The n's made an appearance. We kind of ignored it for a little bit. We don't want to ignore everything. We still want to deal with our m's, right? But we ignored the n's because it was a second variable. Let's pull it back to something that we know and then address it at the end. So if you are looking at something that doesn't have a greatest common factor with a variable, but you have a squared term at the end, this is how you address that. All right, here is number 8. If you've got number 8, move on to number 9. What is the standard form of this following polynomial? We want to start with the biggest exponent first, and the biggest exponent is x to the 4th. No changes made other than its position. The next biggest is a positive 3x cubed. And then we have a negative 2x squared. We don't have any x's, that's okay, no worries. But we do have a plus 9. If we were going to name it, we would name it quartic 4-term polynomial, because it has an x to the 4th. X to the 4th is quartic. You should have that in a table somewhere. There are 1, 2, 3, 4 terms. That's why it's a 4-term polynomial. Some of you are looking in the wrong places to name things, so I just want to make sure we're clear on that. All right, here's number 9. Classify by degree and number of terms. That means name this. So this is a cubic binomial. It is an order in standard form, so the 3 is the cubic. The binomial is that there's 2 terms by, just like bicycle, by meaning 2. All right, factor completely. There's the answer. If you got it right, move on. If you didn't get it right, stick around. All right, greatest common factor of 12, 29, and 15. There isn't one, so we're going to do slide. and slide that 12 to the end. I broke out my calculator here. We have 15 times 12 is 180. So I've got x squared minus 29x plus 180. I need to find two numbers that multiply to give me 180 and add to give me negative 29. Those two numbers, well, I know it's 1 and 180, 2 and 90, 3 and 60. That's not helpful. 4 and, let's see, 180 divided by 4 is 45. 5 and 36. 6 and 30. We're getting closer. I do know that both of these have to be negative. Not 7. I think I can I can't divide by 8. I can divide by 9. 9 and 20. I think that's it. Negative 9 and negative 20. Stick with it, but don't give up. All right, so that means I'm dealing with x minus 9, x minus 20. All right, I did my slide. I've got my factor. Now let's divide. I have to divide by what I multiply by. That's why I circle this. Divide by 12, divide by 12. The most common thing is that I need to reduce these fractions, and that's been the most common problem. If you do not reduce these fractions, you will not get the right answer. People have been sliding 12s in the front, and 12x times 12x is not 12x squared. 12 times 12 is 144. That's way too big. If you are not reducing these fractions, you're not going to get the right answer. So reducing 9/12, you get 3/4. Reducing 20/12, you get 5/3. Can't keep the fractions there because I don't have fractions in my beginning part, so we're going to bring these up to the front. And I'm going to have 3x, I'm going to have 4x minus 3, and I'm going to have 3x minus 5. And there is my answer. And I should multiply to check, and you should too. But I'm moving on because I'm trying to be quick. So make sure you multiply to check. All right, find the difference. Here's the answer. If you've got it, move on to the next one. All right, we are going to distribute this negative only to the second set of parentheses. And then we're going to combine like terms. So a negative times x is a negative x, and negative times 3 is a negative 3. We're going to combine like terms. Now, the only like terms I have to combine are the x's and the constants. I can't combine an x cubed and an x squared, and there aren't any other x cubes or x squared, so those aren't going to change. Negative 4x minus x is negative 5x. 1 minus 3 is negative 2. Notice my exponents aren't changing. They only change when I multiply or factor. I am subtracting. Exponents do not change. Only combine like terms. Variables and exponents have to match. They do not change. All right, find the product. You're multiplying. You can do this a couple different ways, but what I'm going to do is I'm going to start with 12x squared, and I'm going to multiply it here and here. It's a trinomial times a binomial. I should end up with 6 pieces. So 12 times 2 is 24. X squared times x is x cubed. 12 times negative 3 is negative 36. X squared. Now I'm going to switch, and I'm going to do negative x times 2. Negative x times 2x is negative 2x squared. I'm going to put it underneath my x squared I already have. Negative x times negative 3 is a positive 3x. Now I'm going to distribute here. 6 times 2x is 12x. I'm going to put it underneath my 3x I already have. 6 times negative 3 is negative 18. You do not have to organize it the same way I do, but it is something that you can do to help you keep up with what you're going to combine. So I've got 24x cubed. Negative 36 plus a negative 2 is a negative 38x squared. 3 plus 12 is 15x minus 18. All right, here is number 13. If you got number 13, move on to 14. All right, so what is the result when subtracting this from this? So you have to know how to set it up. So after the from is the part that we're going to start with. I'm wrapping it in parentheses, but that part is actually not necessary. Here is where parentheses are necessary. So I'm subtracting that p squared minus 4p plus 1 from this. Now, one thing that I like to do is I like to just play around with numbers. If I was asked, what is the result when 1 is subtracted from -5? That would mean I would need -5 and subtract 1 off of that. So that can kind of help me with the order of things. Setting things up is important. You've got a couple of those on your test. All right, we're going to distribute that negative. So this is 3p squared plus p minus 5 minus p squared plus 4p minus 1. Everything in that second parenthesis has to change signs. And now I'm going to combine like terms. 3p squared minus p, 3 minus 1 is 2p squared. 1p plus 4p is 5p. And then -5 and a -1 is -6. All right, classify degree and number of terms. This is naming. This is a quadratic trinomial. If you got it, move on. If you didn't get it, this is a 2. 2 means quadratic. There are 1, 2, 3 terms. That means it's a trinomial. Tri meaning 3. All right, find the product. Here's your answer. All right, let's multiply. 4a times 4a is 16a squared. 4a times -9 is -36a. 9 times 4a is a positive 36a. 9 times -9 is -81. Make sure you're good on your multiplying. -36a and 36a will cancel, leaving behind 16a squared minus 81. Those parentheses match almost exactly. All right, factor completely. Here is the answer. If you've got it, move on. All right, there is a greatest common factor in our coefficients. All of these are divisible by 2. So I can take out a 2. Check your x's. I've got an x squared, I've got an x, but I don't have an x here, so I cannot factor out x's. I've got, check your y's, y, y, y. We can factor out a y. Everybody's got a y, so in the distributive property, we're giving stuff out. In the factoring, I'm taking stuff away, so I'm going to take a y away from every term. So that means, let's factor out. So we're going to do 2 divided by 2 is 1. I have an x squared. I take the y away from the first term. 6 divided by 2 is 3. I have an x. I'm taking the y out from the second term. Minus 108 divided by 2 is 54. Take that y away. Now, this has a greatest common factor factored out of it, but I can still keep going because I can factor this. So I want to find two numbers that multiply to give me -54 and add to give me 3. Those two numbers are 9 and -6. So I've got 2y, x plus 9, x minus 6. And then you should multiply to check. I should see a check on your paper. All right, find the product. So we're going to distribute 3xy squared, and this is your answer. If you've got it, move on. If you don't have it, stick around. All right, we're going to distribute, and we're just going to take it one step at a time. We're going to do 3 times 4 and get 12. Now we're going to get our x's, and when we get our x's, we're going to add the exponents. There's a 1 here and a 1 here. So x times x is x squared. Y's, 2 plus 3 is 5. So I've gone through all the pieces, the coefficients, the x's, and the y's. Now I'm ready to distribute here. So now I've got 3 times 1, that is 3. X, I've got 1 and 1, add those exponents, x squared. Y, I've got 2 plus 1, which is 3. right, we got to do distributive property one more time. 3 times 2 is 6. Inside the parentheses, there are no x's or y's, so I just have x, y squared from what was outside. None of these have like terms. You cannot combine them. You have to keep them separate. But because there are mixed variables, you can have them in a different order, and that's okay. There is no standard form here. All right, 18. Here's the answer. 18, they have a greatest common factor of 5. If you try to do the square root method here, it's not going to work because the square root of 5 is a yucky number. It's a decimal that keeps going on and on forever. It's irrational. We don't want to deal with irrational things. We want to deal with nice things. So what we're going to do is we're going to look for a greatest common factor. So the greatest common factor is 5. When I divide by 5, I end up with x squared minus 16. Now this is a special binomial, or a special polynomial that we factored yesterday. I know that it's special because it's a binomial. And so I can use one of two methods. If I don't notice that it's special, I can say what two numbers multiply to give me negative 16 and add to give me, there is no x term there, so add to give me 0. I can't go through that. I can also use my shortcut. I can say, hey, there's a binomial. That means the parentheses look almost the same. One has a plus, the other has a minus. And then I can do the square root idea. The square root of x squared is x. So I put an x in the front. The square root of 16 is 4. I put a 4 in the back. But if you use the blanks, what are two numbers that multiply, give you negative 16 and add to give you 0? Negative 4 and 4 are those numbers. So you have multiple ways of doing it in case you do not catch that there is a shortcut. You should multiply to check here. All right, find the sum. Here is the answer. If you're good on this one, move to number 20. Okay, the sum, I'm going to combine like terms. I've got an x squared here and an x squared here. I do not have to distribute that plus. I can if I want. 5 plus a negative 10 is a negative 5x squared. I have xy's here and here, so 6 plus 2 is 8 xy. I have negative 3 xy squared plus 2 xy squared. Negative 3 plus 2 is negative 1, or negative xy squared. Again, standard form isn't necessary here because we have mixed variables. But as long as you have the right stuff with the right coefficients and the right exponents, you should be okay. All right, here's the last one. If you got it right, hang on because I do want to tell you something at the end of this. So this is, again, one of those binomials. You can do slide and divide. It gets a little messy and the numbers kind of get a little large. But 36 is a perfect square. 49 is a perfect square. I have a plus and a minus to give me that negative 49. So the square root of 36 is 6. The square root of c squared is c. The square root of 49 is 7. Multiply to check. So it is straightforward from there. Okay, so you have a test. You can either take it today or tomorrow. You have a polynomial review that you need to turn in by Friday at midnight at the latest. If you turn it in after midnight, it won't let you turn it in. So you've given up your extra credit opportunity. I should see work on just about everything, like the naming polynomials and stuff like that. You can't show any work. But I should see multiplying to check if you're factoring. If I don't see the multiply to check, you're not going to get credit for it. All right, from this point forward, a couple things are going to happen. From this point on, you do not have to, once this polynomial review is turned in, you no longer have to check by multiplying. Now, I highly recommend doing that on the test. But if you are good and you're confident in your answer and you do not need to multiply to check on the test, you don't have to multiply to check. But only after the polynomial review is done and turned in. All right, the other thing I'm no longer requiring is, remember how it's like blank times blank equals 8 and blank plus blank equals 6. That work is no longer required after the polynomial review is submitted. So on the test, you do not have to have that. You should be doing that, and if you get stuck, you should be using that it is a strategy for you, but it's no longer a requirement. In the past, you were required to show your blanks. So have a wonderful fall break. Once you take your test, you're done, unless you're missing stuff from me. And if you're missing stuff from me, you're going to probably get an email about what you're missing, and I need you to figure out when you're going to do it. Respond to me. Don't ignore me. All right. Bye, guys. See you after fall break.